It's visible.
It's visible?
Yeah.
Okay.
Yes, sir.
Okay, great. So we'll continue from where we left off. Next question. So question number 118. So let me just ensure that my stylus is working fine. So stylus, I hope you're able to see it, right? I'm just doodling.
Yeah. It's visible.
Okay.
Yes, sir.
Yeah. So here we go with question number 118. So this is how the question reads. In Young's double slit experiment, if the separation between coherent sources is halved and the distance from the screen and coherent source is being doubled, then the fringe width would become. So then what is the fringe width? Okay, so that is the question. So for that, we will have to know what is the relation between fringe width. So any idea? Fringe width or a formula? If you can remember, you can tell me. So last class also we have learnt about that.
No idea, sir.
Okay. So fringe width has got the relationship. I'll just write it on the screen. It is given by beta. This is a symbol for fringe width is equal to d upon d times lambda. So this is the formula for fringe width. Now here you have two different d. So in Young's double slit experiment, namakita rendu screen irukum. You will have two different screens. One screen is where you have two slits. So we will have two slits, and here is where you have the light source. Okay. So the distance between the slit and the screen, that is the second screen. So we take that as capital D. Okay. And the distance between both the light sources that you can see here, where we have two light sources, let me call it L1 and L2. So this is small d. Okay. So fringe width is given by this relationship. So light is being emitted from these two sources. Now they go and they interfere at a point in space like this. And then we try to find out what is the fringe width. Okay. So that's a basic idea, where lambda is nothing but wavelength. So in this question, what are they telling here? They're telling you that the distance of separation is being halved. Okay. So distance is being halved. That means it is made 1 by 2 than what it was before. So what is going to happen to the distance between the screen is the question. So using this formula as the base, we are going to approach this question. Okay.
Okay, sir.
Yeah. So we are using this, make d as d by 2. And then you try to tell me what is going to happen in this case. So as beta is equal to, I'll solve here because I drew the diagram there. So lambda into capital D upon small d. So now they are telling we are halving the distance. That is, our new distance, small d, is becoming half than what it was before. So we will say it is d by 2. Or even the d dash in follow. So let me call the new distance after making it half is d by 2. And the distance, capital D, is nothing but the distance between the slit and the screen. That is made twice as per the question. So now I'm going to substitute in the formula for fringe width, which says lambda times d dash upon d, small d dash. So if I go and substitute the values, so I would get, so in the place of d dash, I'm substituting 2d. In the place of small d dash, I'm substituting d by 2. You know that 2 would get reciprocaled. And ultimately you would get 4 times lambda d by d. So lambda d by d is nothing but fringe width. So I can say 4 times beta. Okay, so it is becoming 4 times than what it was before. And so that is the idea. Okay.
Option 1, sir.
Yeah, so it becomes 4 times. Option 1 is true. Okay, so that's the formula is what you will have to remember in this case. So with that, we'll move on to the next question. Yeah, can you read this question for me? Question number 119.
A capillary tube of radius R is immersed in water and
Yeah.
water rises it to a height h. The mass of the water in the capillary is 5 gram. Another capillary tube of radius 2r is immersed in water. The mass of the water that will rise in the tube is
Yes. So
option
what
1.
is okay? So what is the capillary rise is what they're asking. So you have 4 options here. So as we read the question, you can see radius is r. Once the capillary tube of radius r is immersed, it is raising to a height h. Okay, is what they are told. And mass of the capillary, water in the capillary is 5 grams. So another capillary tube is 2r, it is immersed in water. And what would be the mass of the water that is going to rise? Okay, now here we are going to write the relationship for capillary. That is for the radius. So let us say we have 2 cases here, case 1 and case 2. So case 1 is where you are immersing the capillary tube of radius r. Case 2 is where I am having a different capillary tube of a different radius, that is twice than what it was before, that is 2r case. So let me say r1 is equal to r, height h1 is equal to h, that is the first case. And what about r2, second capillary tube, it is twice, so which is 2r. Okay, that is what we have. So the product of radius and the height of the capillary is always constant. Okay, so r times h is going to be constant. So we can establish that r1 times h1 is equal to r2 times h2. So we can relate like this. So when you go for a relation like this, you can find out what is h2. So what is h2? When you go to equate them proportionally, both of them, substitute the values. So r into h is equal to 2r into h2. r will get cancelled and you get h2 is h upon 2. Correct? So you get the height. So we have got the relation of the height for the second capillary tube having a radius of 2r. Now we are relating, we need to find out what is the mass. So for mass, you obviously know that mass can be expressed in terms of density and volume. So we go for that relationship. So you know that density is mass by volume. So what is mass? It is density times volume, isn't it? Go for a cross multiplication. Substitute the values now. Density is rho and volume. Now volume is, when you take a capillary tube, it is in the form of a cylinder. I hope you know the formula for volume of a cylinder. Base area into height, right? So base area is circle area. So pi r square into h. Okay. So this is the formula for volume. Pi r square h is nothing but the volume of the cylinder. Okay, that is the capillary tube. Now I'm going to go and substitute the values that I'm having. So mass of the water in the first capillary tube, which is nothing but 5 grams. Okay, so m1 is 5 grams. So I can go and substitute. So you can simply say 5 is equal to rho into pi r square h. Okay, so this is one relation that I'm having. This is for the first capillary tube. Same way for the second capillary tube, mass m2 is equal to rho into pi r2 square h, r2 square h2. So we can call it like that. Okay. And then we are going for an equation. So we are equating both the equations. Okay, because mass is nothing but going to be same because it is the same water that is being transferred to the other capillary tube. So mass is constant. So as m1 is equal to m2, we can equate both the equations. So you would get, one second, we don't equate, one second. So here what's happening is, so m2 relation I have written, I have not written m1. m1 is 5 grams on the top, m2 I have written another equation, isn't it? So mass of that water that is going to raise in the second capillary tube is what we are finding. So here, substitute the values that you have. So m2 is equal to rho into pi. What is R2? R2 is given in the question as 2R. Substitute the whole square times height. Height also we have found out. H2 is h by 2 into h by 2. Okay, I'm substituting it. Now go for the simplification. Okay, so simplify it. So once you go for the simplification, what are you getting? You know that pi r square h is nothing but your volume. Okay, again that is nothing but density times mass. So we can say it is 2 into 5 grams. So 2 times 5 grams would ultimately give you 10 grams because it can be expressed as 2 times. After you cancel out this 2 and that 4, you are left with one more 2. That is the meaning. Okay. So 2 times 5 grams, you will get 10 grams. So the answer is 10 grams. So the answer is option 1. So this is how you approach this question. Whenever you have capillary tube, 2 different tubes with different radius, and you want to find out what is the water, height of the water that is being raised. So you would apply this relationship and find out. Okay. So this is how you approach this question. First, find out the height. Once you have found the height, then you go and substitute, and then you calculate what is the mass. So that for that we use the formula mass is equal to density times volume. That is the relation we use. Okay. So this is how you calculate. So I have shown you all steps here. This is how it is being done. Okay. So we'll move on to the next part. I'll just erase this. Okay. So now moving on to the next question. Question number 120. The cylinder contains hydrogen gas at a pressure of 249 kilopascal and a temperature of 29 degrees Celsius. Okay, and density is also given. Its density is what you will have to find, and they have given you the constant, gas constant is given. Universal gas constant value is specified in the question. So you will need to find out.
Sir, ideal gas equation.
Okay, ideal gas equation. So what is the ideal gas equation? PV is equal to
nRT.
Yes, nRT, good.
Sir, இப்போ வால்யூம் வந்து pi r square h.
Okay.
சிலிண்டருக்கு அப்புறம் n வந்து நம்பர் ஆஃப் மோல்ஸ் வந்து 29 கிலோ பாஸ்கல்.
29
kilopascal.
29 kilopascal. How will that be number of kilopascal is pressure, yeah?
249, sir.
Yeah. Pressure is 249 kilopascal, which is 10 to the power 3 pascals. Okay.
Temperature வந்து 300, sir.
Temperature.
273 plus 27 degrees Celsius.
Celsius வந்து we are converting to Kelvin, so 300. Okay.
Our universal gas constant 8.3 joule mole power minus 1.
Correct. That is given. So you go for a rearrangement. So number of moles, how much did you say?
249, sir.
Number of moles, n, small n.
Yes, sir. Sorry, sir.
It cannot be 249. That is pressure, yeah.
Sorry, sir.
So it cannot be 249. So what is the number of moles? Mass upon molar mass, and the relation then we use pannu. Okay. So use the relationship mass upon molar mass. So molar mass of hydrogen, obviously you know how much it is. Okay. Hydrogen gas abdin solirukanga. So obviously it is going to be H2. I mean for H2 you know it is going to be 2. Okay. So substitute pannunga, easy. So when you substitute, I'll solve it here. So you started off well. So you know that PV is equal to nRT. Okay. So namakku vandu we wanted to find out what is density. So we can say still PV is equal to number of moles when the mass upon molar mass into RT. சரியா? இப்போ இங்க வந்து we need to relate density. Okay, density is mass by volume அப்படிங்கிறதுனால mass by volume fraction வந்து நீங்க அதை கொண்டு வரணும். So I am going to shift this molar mass to the top and volume to its place. அப்போ என்ன ஆகும்? I can say pressure into molar mass is equal to mass by volume into RT. Now I got mass by volume. Mass by volume is nothing but density. So density is equal to pressure times molar mass upon RT. Okay, this is how I bring the relation. Next I go and substitute. Pressure is given as 249 kilopascal. So 249 into 10 power 3. Mass of hydrogen. Hydrogen atom has got, hydrogen gas has got 2 atoms of hydrogens bonded together using a sigma bond. So it is 2 into R வந்து questionலயே specify பண்ணிருக்காங்க. So which is
8.3.
correct. 8.3 அது கீழ வரும். It is divided by, correct. Upon 8.3 into 300. அவ்வளவுதான். இது simplify பண்ணா you will get the answer. Go for a simplification. Okay. So how much you're getting if you simplify this? So either one day you have to go for a simplification. Take your time and tell me how much you're getting. And the 10 square மேல கொண்டு போங்க. It becomes 10 to the power to minus 2 plus 3 is 10. So 110 will definitely remain. அதுக்கப்புறம் 249 into 2 498 upon 3 பண்ணுங்க. எனக்கு கீழே ஒரு 3 இருக்கு. ஸோ அப்போ அது போகுது. இட் இஸ் டிவிசிபிள். 166 வரும். 166 upon 8.3. Will fetch you the final answer. Okay, and don't forget to convert grams to kilograms. You know, grams is there, so 10 power minus 3 இருக்கும். Okay, so don't forget to convert that. That is one aspect that you will have to keep in mind. Okay, so 1.5 வருது எனக்கு. simplify panna. So how much is 1.5? 0.2 then. So it is 0.2 kilograms per meter cube. So grams வந்து kilograms வந்து convert பண்ணுங்க. Okay. So that is the answer. The answer is 0.2 kilograms per meter cube.
0.2, sir.
Amma. So that's how you do this question. Is that clear?
Yes, sir.
Yeah. So now moving on. That's the approach to solve this. Move to the next question. Question number 121. Yeah. An iron rod of susceptibility 599 is subjected to a magnetizing field of 1200 ampere per meter. The permeability of the material of the rod is. So what is the permeability is what they're asking. So you have to find out what is mu. Okay. Mu naught கொடுத்திருக்காங்க. Relative, the permittivity is given. They're asking what is permeability. You take mu naught as 4 pi into 10 power minus 7. So நம்ம என்ன பண்ணலாம்? What relation can we use here? What is 599? Susceptibility. Susceptibility is given by the symbol. This is a symbol for susceptibility. Chi அப்படின்னு சொல்லுவாங்க இத. Okay? CHI, which is pronounced as chi. So chi is 599. Okay? That is mentioned. That's specified here. And magnetizing field is also given. So what is the relationship? You know, relative permeability is equal to susceptibility plus 1. This is the relation we have. So in the relation that I use pannu. Relative permeability is equal to susceptibility plus 1. Use the relationship, substitute the values. So you go for a substitution. So what is mu r? 599, what pannona? 600. So you will get 600. Mu r is 600. Once you got mu r, the relation between relative permeability and permeability is, you can write mu as mu naught into mu r. Okay. That's it. So go for substitution. Mu naught value question liye kuduthirukanga 4 pi into 10 to the power minus 7 into mu r is 600. So simplify பண்ணுங்க. In terms of pi வச்சுக்கலாம். 6 4s are 24. So we can write this as 24 pi into 10 to the power of minus 5. Isn't it?
Yes, sir.
Yeah. Tesla meter ampere inverse. Significant figures நீங்க எழுதுனீங்க அப்படின்னா it will be 2.4 pi into 10 to the power minus 4. Yes. So answer வந்து is option 3. Good. That's all. So again the formulas. These two formulas you will have to remember. The ones I have boxed. Okay. Fine. So now moving on to the next question. Question number 122. Find the torque about the origin when a force of 3 j cap newtons, so this is when a force of 3 j cap newtons acts on a particle whose position vector is 2 k cap meters. எல்லாமே vector notation கொடுத்திருக்காங்க. Okay, everything is in terms of vector notation. இப்போ டார்க்னு சொல்லி கேட்டிருக்காங்க. What is the formula for torque? You know that torque tau is equal to
Fn.
Yes.
Fn.
It is a cross product of position vector and force vector. So r bar cross f bar. Okay. This is what is torque relationship, a vectorial formula. Okay. Now you go for substitution. Position vector ஏற்கனவே questionல வந்து they have already mentioned. So what is the position vector? In place of position vector you will substitute 2k cap into your force vector is 3j cap. Okay. So 2 3s are 6. You can directly do that. So this is 6. What is j cap cross k cap? I mean, that
I
is k cap cross j cap. Inge vande first k and then you are crossing with j. You are not going in order, right? So you are going the other way around. So உங்களுக்கு vectors I hope you are already aware. I first வரும், அதுக்கப்புறம் j, அதுக்கப்புறம் தான் k வரும். Okay. ஆனா இங்க நம்ம ஆப்போசிட் டைரக்ஷன்ல போறோம். ஆப்போசிட் டைரக்ஷன்ல போனோம் அப்படின்னா you will take the opposite sign also. So k cap cross j cap will give you minus I cap. Okay, that
Option
is
1.
That is something you will have to remember. So the answer is minus 6 I cap. Okay, so which is answer is option 1. Okay, this is how you approach this question. Fine, is it clear? So the formula and how we done, how we have solved it. Okay, yeah. So we'll move on to the next question. Question number 123. The average thermal energy for a monoatomic gas is, what is the average thermal energy for a monoatomic gas? Where Kb is a Boltzmann constant and T is nothing but the absolute temperature. Again, it's again direct formula only. If you remember the formula, you will come to know. The formula for the average thermal energy for a monoatomic gas is given by E is equal to 3 by 2 Kb into T. Okay, so direct formula they have asked. So 3 upon 2 kBT is option 4. Okay, where Kb is Boltzmann constant and T is your absolute temperature. Simple. This is just formula based question. So you remember the formula. In monoatomic gas, when this is a formula. அதே மாதிரி diatomic இருக்கு, triatomic இருக்கு. Okay. So we'll go to the next one. Yeah, question number 124. Assume that light of wavelength 600 nanometer is coming from a star. So they have specified wavelength lambda. Okay, I am writing it. So wavelength lambda is 600 nanometer. It's coming from a star. The limit of resolution of telescope, whose objective has a diameter of 2 meters. So the diameter of the objective D is nothing but 2 meters here. That is also specified. Okay. இப்போ next நீங்க என்ன பண்ணணும்னா wavelength பாத்தீங்கன்னா it is not in standard units. Okay. Convert it to standard units. So lambda converting 600 nano to meters. I hope you know that nano is 10 to the power minus 9. Okay. So go for a simplification. You can write it as 6 into 10 to the power of minus 7, isn't it? Because minus 9 plus 2.
Yes, sir.
Minus 7 meters. Right? So we can write it like this.
Option 2, sir.
Yeah. Okay, you found out the answer. Option 2. Okay, we will check that. Now, what is the formula for the limit of resolution? It is given as delta theta. Okay. So delta theta is equal to, which is 1.22 into lambda upon D. This is the formula for limit of resolution. Okay. So you have to substitute in this formula. So you get 1.22 into lambda when this 6 into 10 to the power minus 9 divided by D is nothing but 2. 2 ones are 2 3s are 3 into 1.22.
Option 3, sir.
3.66 வருது into 10 to the power minus 9. Okay.
3, sir.
Sorry, 10 power minus 7. Sorry, not 9, 7. ஏன்னா நான் simplify பண்ணிட்டேன். Nano வந்து I have incorporated. Okay. Yeah. So 3.6 into 10 power minus 7. Yeah, the answer is here, option 3. Okay. That's it. That's how you do it. Is it clear? This is how you approach this question. Again, formula plays an important role. Limit of resolution formula, we will have to remember. Okay. Next, question number 125. Light with an average flux of 20 Weber per centimeter square falls on a non-reflecting surface at normal incidence having surface area of 20 centimeters square. The energy received by the surface during a time span of 1 minute is. So what is the given data here? They have given you the intensity, Weber per centimeter square அப்படிங்கிறது வந்து intensity of light. Okay, so I is given as 20 Weber per centimeter square. Fine, that is specified. Time t is also given as 1 minute. Convert it to seconds, which is 60 seconds. அதுக்கப்புறம் வேற என்ன கொடுத்துருக்காங்க? They have also given you the area. So area is 20 centimeters square. Okay, so all these are given. Fine. So what is the relationship between, and they are asking you what is the energy. You need to remember that energy can be written as the product of intensity into area into time. E is equal to IAT. Okay, is a relationship. Go for a substitution. Go and substitute the values. I is 20. Area is also 20. Time is 60.
Option 1, sir. Option 1.
So, yeah, 2 to the 4, 4, 6 are 24. 2 to 10 to the power 3 joules.
Option
So,
1, sir.
yeah, answer is option 1. 24 into 10 to the power 3 joules. So again, the formula which we used here is E is equal to IAT, where E is energy, I is intensity of light radiation, A is area, and T is time. Okay, so that needs to be remembered. Okay, moving on to the next question. Yeah, could you please read this question for me?
The ratio of contributions made by the electric field and magnetic field components to the intensity of an electromagnetic wave is
Yes.
equal speed of electromagnetic wave.
Yeah. So they're asking what is the ratio of the contributions made by the electric and magnetic fields. Okay. So electromagnetic wave means that is your electric field and the magnetic field both are present together. Okay, they coexist together and they are perpendicular to the axis in which they are propagating. All right, so that's what is an electromagnetic wave. So the directions of propagations of the wave are rather perpendicular to each other. The electric and magnetic fields are also, mutually perpendicular to each other. And because of that, the contribution of both the fields is going to be same. It's going to be equal. Okay. So the answer is 4, which is 1:1. Both of them contribute equally. Okay.
Okay, sir.
Yeah. So I'll write here the reason is the contribution of electric and magnetic fields are equal for an electromagnetic wave. That is EMW, which is electromagnetic wave. So answer is option 4. Okay, moving on to next question. Question number 127. You have a graph here. Which of the following graph represents variation of resistivity with temperature T? Okay. So resistivity rho and temperature is T for copper. So what is going to happen for the corresponding graphs? So you know that copper is what? Is it a conductor, semiconductor, or an insulator? First, we will have to identify that. Okay. So you know that copper is copper a good conductor? Does it conduct heat? Does it conduct electricity? Do we use copper bottom vessels in our daily life? Have you seen some vessels, cooking utensils or the vessels, you can see that they have a copper bottom. Why do you think they, have a copper bottom? It is for a quick conduction. Okay.
Should
Yeah. To increase the conductivity of heat. So its conduction rate is quite faster, and that's the reason you have a copper coating or a copper finish at the rear end of the vessels. So therefore, copper is a conductor. For conductors, what is the relationship between temperature and the resistivity? Okay, so obviously resistivity would be higher or it would be lesser is what we are trying to identify. Now, as the time is going to decrease, that is when temperature is going to increase, then there is going to be an increase in resistivity. Okay, so a variation of resistivity of copper with the temperature is going to be a parabolic nature. It is going to increase proportionately. It is going to increase exponentially because it's with time, the relaxation time, the temperature is going to increase, and so does the resistivity of copper also, because R is equal to rho L upon A. That is the relationship that we have. Okay, so which of these graphs represents a parabola? Quite simple. Which is a parabolic graph?
Option 4, sir.
Option 4. Okay, but is it increasing there? The curve, the way the parabola is drawn, is decreasing parabola. Increasing parabola is the first one. Okay.
Option 1.
Yeah, first one. That is also correct what you said, but that is also a parabola which is rather decreasing. Okay, fine. So the correct answer is option 1. All right. Next question, number 128. Yeah, just go through the question, just read it. We'll see how to solve. The question says the quantities of heat required to raise the temperature of two solid copper spheres of radius R1 and R2 through 1 Kelvin. Then what should be the ratio if you're going to raise them through 1 Kelvin? Okay. So you can see that the quantity required to raise the temperature of solid copper by 1 Kelvin is nothing but that is the specific heat capacity that they are referring to. Okay. So you make use of that relationship. So the formula for specific heat capacity is what we are going to, make use of. Okay. Now specific heat capacity is going to be same for both of them because they are two identical solid copper spheres of radius R1 and R2. Fine. So we are going to find out the ratios of both of them. That's what they're asking us. Okay.
Okay, sir.
Yeah. So find out the corresponding ratio. We need to know what is the relationship or what is the formula. Okay. So change in heat we'll take for the first sphere as because R1 and R2 is a notation that they have given. So we'll take it as delta Q1 upon delta Q2. Okay. So that can be written as density into volume, which is rho into volume will be different because both of them have different radii. So d rho into V1 into delta T. Okay, that is change in temperature. Same way for the second one, rho into V2 into delta T. Now delta T is 1 Kelvin, so we can just cancel them out. Okay, and density also cancels out, same material. So substitute volume formula, volume of a sphere. So you know the volume of a sphere is 4 by 3
Pi r.
pi
Yeah.
r1 cube. Yeah, not square, it is r1 cube upon,
Divided by 4 by 3 pi r cube. Pi
yeah,
r2 cube.
yeah, r2 cube. So 4 by 3 would get cancelled, and pi also would get cancelled off. Then you go for substitution. R1 by R2 the whole cube you can write, which can also be written as R1 is nothing but R1 is 1.5 times R2. Okay. So 1.5 times R2, that is R1 divided by R2. So R2 cancel, whole cube. 1.5 can be written as 3 by 2 in fraction. 3 by 2 the whole cube. So how much is 3 by 2 the whole cube? 3 cube is 27 and 2 cube is 8. So the ratio turns out to be 27 upon 8, which is option 3. Okay. So the third option is correct.
Option 3, sir.
Yeah, option 3. Fine.
Sir,
This is how you solve. Yeah.
sir, one doubt, sir. இப்போ 1.5 cube வந்து 375 தானே சார்?
1.5 நம்ம வந்து இங்க ரேஷியோ கண்டுபிடிக்கணும். ஸோ அதனால 1.5 வந்து நம்ம ஃப்ராக்ஷனலா எழுதணும். So 1.5 can be written as 15 by 10, no? You write it in terms of fraction, don't you think you will get 3 by 2?
Yes, sir.
Isn't it? So ratio, whenever you calculate, don't go for a decimal cube. Decimal cube will not fetch you the answer. Obviously, 27 by 8, நீங்க decimal பார்த்தீங்கன்னா அந்த answer தான் வரும். But the answers are given in terms of ratio of the integer value. So therefore, convert it into an integer and then keep it as a ratio itself, and then express it. 3 by 2 the whole cube will give you the answer as 27 upon 8. Okay.
Okay.
That's it.
Okay.
Yeah. Yeah. Next question number 29. A resistance wire is connected in the left gap of a meter bridge that balances a 10 ohm resistance in the right gap at a point which divides the bridge wire in the ratio 3:2. Okay. If the length of the resistance wire is 1.5 meters, the length of 1 ohms resistor wire would be. So what is the length of 1 ohm resistance wire? Is what is the question. Okay. Now you know that meter bridge, you have a resistance box where you have known resistance, and then you are having a unknown resistance X. Okay, all this is there, and then this is connected to a cell with a plug key, and in between you have a wire. The wire is of 1 meter length, and between your resistance box and your unknown resistance you have a galvanometer. To this galvanometer you have a jockey, and this is how the circuit looks. So we can name it as A, B, and this center part as C. Okay. So jockey is at a point, of the meter bridge. The jockey, you would hold it stationary at a point after you move, so that the galvanometer is going to show null deflection. That means the meter bridge wire is balanced. So you take the left side length as L and the right side length as 100 minus L. Okay, 100 centimeters, which is nothing but 1 meters. The remaining length you can find out. Okay. So this is all about the meter bridge. So what is the balancing condition for a meter bridge? resistance box, whatever resistance you're applying. So ratio of the resistance to the length. So RB upon L is equal to X upon 100 minus L. That is the relation that we have, okay, for the meter bridge circuit. Now, in this question, they have given you 10 ohms resistance in the right gap, they are saying. So right gap has got 10 ohms resistance, okay.
Okay, sir.
Yeah, so that is what is specified. And they are telling the ratio also, balancing point ratio is also given. So you can simply say R upon X is equal to 3 by 2. That is the relation that we have as per the given question. Now, when you go and substitute the values, you can find out the value of R, provided that X is being specified. So what is R? 3x upon 2, which is 3 into 10 upon 2. 3 tens are 30 upon 2 is giving you 15. So you find out R as 15 ohms. Okay, that's how you calculate R. Once you have calculated R, you can find out the length of 1 ohm wire. Okay, because the length of resistance wire is 1.5 meters. So the length of 1 ohm wire would be, how much is that going to be? L is equal to 1.5 upon 15. Okay, so you can find out what is the length of 1 ohm wire. So how much is that going to be? 1 upon 10, which is nothing but 0.1 meters. So 0.1 meters in terms of significant figure can be written as 1 into 10 to the power minus 1 meters. That's it. So the answer is option
4, sir.
Option 4. Yeah, not 3, 4. 1 into 10 to the power minus 1. So this is how you solve this question. Okay. So 1.5 divided by, and the R, that R is what? Is 15. That's why I've put 15 there. Do not get confused. So 1 upon 10 varo. So you get it as 0.1 meters, which is nothing but 1 into 10 power minus 1 meters. Is it clear? This is how you approach this question. Meter bridge concept is applied. Okay. Next we have question number 130. The increase in the width of the depletion region in a PN junction diode is due to, again, it's from the chapter semiconductor devices and electronic circuits. So what is the reason for increasing in the width of a depletion region? When you have N and P type being connected together across a battery or a potential, so what's going to happen? Because you have no electrons, right, and holes. There is no electrons and holes in the region. Okay, because it is only in the case of a reverse bias. Okay, so it is reverse bias. So the answer is going to be option 4. Fine. The reverse bias lada, it will not going to conduct, and it is the depletion width will keep on increasing. It starts building up because of the absence of electrons and holes in that region. Okay, so this is a direct question only from theory of PN junction diode. That is the answer for question number 130. Next question number 131. Could you please read this?
A 40 mu F capacitor is connected to a 200 volt, 15 hertz AC supply. The RMS value of the current in the circuit is nearly option 1 2.5 ampere, option 2 25.1 ampere, option 3 1.7 ampere, option 4 2.05 ampere.
Yes. So here they have given you capacitor value 40 microfarad capacitor, and source of the voltage is 200 volts, frequency is 50 hertz, AC supply. They are asking me what is the RMS value. Okay, IRMS is what we will have to find out. Because your circuit is a AC capacitive circuit, because you have a capacitor connected to a AC source. Okay, so AC capacitor circuit looks like this. I have a capacitor connected to an AC source which is clocked at 200 volts and 50 hertz. Okay, value of capacitor is 40 microfarad. Now, having this in mind, you have to find out what is the impedance of this circuit. The impedance of the circuit would be equal to what? It is going to be equal to capacitive reactance, which is given by XC. So XC is nothing but 1 upon 2 pi FC. Okay. So that is the formula for capacitive reactance. So 1 by omega C in eluduvom. That omega is nothing but 2 pi F. Seriya? So we will get 1 by 2 pi FC, where F is your frequency. Okay, that is linear frequency of the circuit, and C is value of capacitance. All right. So first you find out that, and then you go for a substitution. So IRMS is what they are asking, is equal to Ohm's law. From Ohm's law, you know that V is equal to IR. So I is equal to V upon R. Here our R is nothing but your capacitive reactance. Okay. So you need to just substitute those values. So XC is 1 upon 2 pi FC. So your answer is V into 2 pi F into C. V is 200. I'm substituting the values into 2 pi. F is 50 and C is 40 microfarad, which is 40 into 10 to the power minus 6. To be simplified. Okay. Pi you can take it as 3.14. So 2 into 2 is 4. 4 5s are 20. And 20 times 4. 80. Okay. All the numbers I multiplied. Then the number of tens I am taking. Here it is 2. 10 to the power 2. 10 to the power 2 into 10 is 10 power 3. 3 minus 6 is minus 3 into 3.14. Okay. So 8 into 3.14 into 10 to the power minus 2. 8 into 3.14, value is 25.12. Okay. Yes.
Option 2, sir.
Yeah. Option
2, 25.1 ampere.
Yeah. So into 10 to the power minus 2 we are having. So if you are writing in terms of significant figures, so you will get us to, what do you get, 2.51? So 2.51 is coming, no? Or is it 25.1?
Option 1, sir, 2.5 ampere.
Yeah, 2.5 is coming. Okay, when you write in terms of significant figures.
Okay.
So 2.5 amperes. The most correct answer is 2.5 amperes. First option. That's it. So this is the formula that we are using. So two formulas are involved to solve this question. First is capacitive reactance and then IRMS formula, V upon XC. Simple. Okay. Next, moving on to question number 132. Taking into account of significant figures, what is the value of 9.99 meters minus 0.0099 meters? This is a question. Simplification again, you'll have to simplify and find out the answer. Yes. Go for a subtraction and tell me how much you're getting. So 9.99 minus 9.9801 you would get, isn't it? How much is, so in this, so answer should have the number of significant figures. So the accurate number is going to be 9.98.
2.
Okay. Yeah, 9.98. Don't go for approximation. Okay. Fourth
Okay.
one. Yeah. So fourth one only. 9.98. That's it. Okay. Simplify and get the answer. So next question number 133. So going through the question. A charged particle having a drift velocity of 7.5 into 10 to the power minus 4 meters per second in an electric field of 3 times 10 to the power minus 10 volt per meter has a mobility of. So you have to find out what is the mobility. Okay. So mobility has got a relation, direct relation with drift velocity. Mobility is given by the symbol mu. This is a symbol for mobility. Okay. So electron mobility is nothing but the ratio of drift velocity and electric field. This is what is the formula for mobility. So I think you have all the data, just need to simplify it. So drift velocity is given in the question as 7.5 into 10 to the power minus 4 divided by electric field is 3 into 10 to the power minus 10. Just you need to go for a simplification. 7.5 upon 3. How much does it give you?
Sir, option 1, sir.
5 upon 2 into 10 to the power of 10 minus 4 is 6.
6, sir. Option 4.
Correct, which is 5 by 2 is nothing but 2.5 into 10 power 6. Answer is option 4. Perfect. Clear? This is how you do this question. Again, this formula for electron mobility you need to remember. All right. So we'll move on to the next question. Question number 134. Yes, could you read it?
In a guitar, 2 strings A and B made of same material are slightly out of tune and produce beats of frequency 6 Hz. When tension in B is slightly decreased, the beat frequency increases to 7 Hz. If the frequency of A is 530 Hz, the original frequency of B will be option 1, 536 Hz, option 2, 537 Hz, option 3, 523 Hz, option 4, 524 Hz.
Yeah. So they have given you a guitar where you have 2 strings. It's made up of strings A and B. And they are telling it is slightly out of tune. It is not in tune. It is out of beat or it is out of tune. And that is having a frequency of 6 Hertz. That is what is specified. Okay. And when the tension of B is slightly decreased, when it is reduced, then frequency is increased to 7 Hertz. Then if frequency of A, the string A is 530, what is the original frequency of B is the question. Okay. So here we write down what are the frequencies given in the question. So frequency is given by the letter mu. So mu A is specified as 530 Hertz. Okay. And mu B, we don't know. We'll have to find it. Okay. So let's keep it as question mark. Now they are saying when they are out of tune, it is 6 Hertz. When they're out of tune, that means you take the difference of both of them. The difference of both the frequencies, that is nu A minus nu B, is 6. Okay, so modulus operator is very important, so you keep them under mod. So modulus of nu A minus nu B, that is because they are out of tune, is equal to 6. So then what happens? Nu A minus nu B is equal to plus or minus 6 because I'm removing the mod operator. So you know what is nu A, we need to find out what is nu B. So nu B can technically be equal to 530 plus or minus 6. Okay. So this is what you get when you go for a rearrangement. So what are the possible values for nu B? It can be either 536 or 524. Two possibilities are there. Okay.
Yes, sir.
Now you will have to choose wisely. Before that, they are saying that in the second case, tension of B is slightly decreased, then beat frequency is increasing by 7 Hz. That means you know that the relation frequency is always proportional to the square of the time period. Okay, I mean square of the tension. Sorry, not time period, square of your tension. So this is what is the relationship. So when I say square root of tension, square root is something to the power 1 by 2. That means, now obviously it has to be less. It cannot be more. Okay. So out of 536 and 524, if you're going to compare, you will have to choose the value which has to be less and not the one which is higher. So out of these two values, which value is lesser?
Option 4, sir. 524
Yeah,
hertz.
correct. 524 hertz is less. So that is the answer in this case. Okay, the higher value you are not going to consider. Okay. So the answer is option 4, which is 524 hertz. That's it. Simple. So we are moving on. So that's how we approach this question. So this is the formula that we have used. Okay, two formulas. Second one, relation of frequency with tension. Okay. Fine. Let's go on to the next question. Question number 135. Two particles of mass 5 kg and 10 kg are attached to two ends of a rigid rod of length 1 meters with a negligible mass. The center of mass of the system from the 5 kg particle is nearly at a distance of. So where is the center of mass of the system? At what distance is what they are asking. Okay. So they have given you the masses. Let us assume. So 5 and 10 kg, let this be M1, let the other mass be M2. Formula for center of mass, I hope you know. XCM is equal to M1x1 plus M2x2 divided by sum of the masses, which is M1 plus M2. Okay. Distance between both the masses is given as 1 meter only. Right?
Yes,
So now
sir.
you go for a substitution. Now they're telling you the ends of the rod is attached to the two ends of the rod with 1 meter of a negligible mass, they are saying. So if you consider one of the points to be the origin, okay, so draw the figure, say this is the rod. At this end I am having 5 kg mass, at this end I am having 10 kg mass. So if 5 kg mass is towards the left and that is the origin, obviously this length would be x1 is going to be 0 and x2 here is going to be 1 meters because the length itself is 1 meter. Okay. So center of mass is what we are trying to find out. Okay. Now if you write the equation of center of mass considering the origin as this point, so you would get m1 into x1, x1 is 0, so m1 into 0 plus m2 into the length of the rod, okay, which is nothing but
10 into 1.
10, right?
Yeah, 10.
Yeah, into 1. So I'm keeping it as 10 into 1. So I'll keep it as M2 into that we have taken as D as per the figure. So I'm generalizing. Divided by sum of both the masses. So that is M1 plus M2. Okay, when you go for adding. So M2D upon M1 plus M2. Then you go for a simplification. Substitute the values and then you simplify.
10 by 15. 2 by 3.
Yes. So 2 by 3 meters. 2 by 3 meters you are going to,
67 centimeter.
in terms of centimeter, you are expressing. Obviously 1 meter is 100 centimeter. So 100 by 3, I hope it is 33.33. Yeah, into 2, you would get 67.
67
Okay.
centimeters.
Yeah, that's it. So that's how you do this question.
Maybe we will close at this Manish because other and அடுத்தது வந்து chemistry தான் வருது.
Ama,
Because
next chemistry questions
even
are
the
coming.
crowd is less, so we will wind up here.
Okay.
Okay. All the best,
So
children.
all the best.
Yeah, students போய் நல்லா எழுதுறவங்க அப்புறம் நெக்ஸ்ட் இயர் கண்டினியூ பண்றவங்க கண்டினியூ பண்ணுங்க. We will
Sure. All
we'll
the best
keep,
for the NEET examination. Hope everything goes well.
Yeah.
Okay. So keep cool. I would say for the exam, don't take